In this Fusion tutorial, we'll quickly model a straight bevel gear. Keyboard shortcuts appear in the bottom left corner throughout the tutorial. Start your sketch on a vertical construction plane for a more intuitive workflow. This 2-point rectangle serves as a rough framework for the detailed sketching that comes next. Sketch loosely within its bounds. You can always refine it with dimensions later. Feel free to use my dimensions or set your own. The ones I'm using are just examples without any specific product requirements in mind when I recorded this. The goal here is to create a shape we can revolve around an axis to form the shaft. Feel free to get creative. This sketch I'm showing is just one way to approach it. To keep things quick and simple, I'll start by laying down the sketch lines, then use dimensions to lock everything in place. Blue lines mean the sketch isn't fully constrained yet, while black lines are fully defined and behave more predictably. It's generally a good habit to fully constrain your sketches, especially later in the design process, but it's not always necessary early on when you're just roughing things out. Fusion helps you while sketching by automatically adding constraints. You'll see their symbols in the toolbar, and if you hover your mouse over any of them, you'll get a quick explanation of what they do. To add some variation to the shaft, you can sketch an arc or any similar shape, then use dimensions and the trim tool to clean up any extra geometry. Oversketching, iterating, and trimming is often faster than aiming for a perfect sketch right away. It also takes the pressure off. Modeling is about exploring ideas, not nailing it on the first try. Watch what happens to the defined black lines when we trim the sketch to fit the new arc. Some lines turn blue, and Fusion shows a warning in the bottom right corner. Constraints were removed during the operation. This isn't a problem, but it's something to keep in mind. Most lines still have dimensions, so it's a good mental exercise to figure out what's missing. In this case, adding a dimension between the end point of the sketch line and the origin fully defines the sketch. At this point, you've got two closed profiles. You could revolve the lower one right away, but your model will be easier to work with if you first trim away the sketch lines you don't need. Once trimmed, activate the Revolve command. Fusion automatically selects the remaining closed profile, so all you need to do is choose the axis. Click OK to complete the revolve. If you ever need to update the shape, just revisit the sketch through the timeline. Before we move on to the head, let's add some details to the shaft. For better visibility, you can apply an appearance to the face we're about to sketch on. Think of it like a visual guide. It's not a construction line, but it helps. Use the same appearance you plan to use for the full body later. This blue shading makes it easier to see where you're sketching. Next, we'll project the underlying geometry to this new sketch. That way, if we ever update the original sketch, this new one will update automatically, keeping the design fully linked. There are plenty of ways to approach the detail we're about to create. Once again, I'm using a 3D modeling method where I sketch, trim, add, and remove geometry. The projected circular shapes act as boundaries for the trim operation, and the end of this rectangle blends nicely with the projected circle. Think ahead to the next steps. You'll need to create a circular pattern, and you'll want this feature to behave as a separate body so it doesn't affect the shaft. That's why I'm choosing to project it as a new body to the opposite end. And remember, this is just one approach. Others might prefer using commands like Loft or Rib to achieve a similar result. Add a full round fillet before creating the circular pattern. Since it's parametric, it'll update automatically if the sketch changes. It's also easier to apply now than after the pattern, and any future changes to the pattern quantity will keep the fillet intact. The blue highlight confirms this part is an individual body. Keeping the design centered on the origin helps us easily choose an axis for the circular pattern. Set the distribution to full and choose a quantity that fits your project. I'm using 30 here, but this is just an example, not tailored to any specific product requirements. Now it's time to create the head. First, I'll measure the diameter. We need to check the size of the sketch we revolved earlier. It's 90 millimeters, so we'll keep that in mind when creating the gear. Head over to the Utilities tab and open Scripts and Add-ins. Select Spur Gear and click Run. You'll see a helpful picture and a few settings in the menu. Change the module to 4. This updates the pitch diameter to 96 millimeters. For a real project, you'd probably fine-tune these settings more carefully, but this will work for this Fusion tutorial. Hit OK, and the new Spur Gear component will appear centered at the origin and in the project browser. Reposition your gear using the Move command. If you followed the first rule of Fusion and placed your design in a new component, you could assemble everything. But we're not doing that here. Don't use joints here. They are the right tool in many cases, but not in this one. We're about to break the gear into parts and not making an assembly. Use the point-to-point move instead. It makes it easy to place the gear exactly where it belongs. Pay attention to the origin point and target point. Make sure you them right. As usual, Fusion helps you snap to geometric centers, which makes positioning much easier and smoother. Do a quick quality check from different angles using the view cube to make sure everything aligns before we move on. Click the small plus sign below the Spur Gear in the timeline to expand all the actions it includes. Delete the pattern, we only need one tooth. Then delete the solid base. We don't need it for what comes next. Now you're left with just a single Spur Gear tooth, and you can use the Move command to rotate it to any angle. I'm using negative 45 degrees for those following along with my dimensions. There's more than one way to solve this. We're using the Spur Gear add-in and then deleting parts of the gear. Not because we can't model a tooth from scratch, but because the add-in is quick, easy, and packed with standardized settings. If you prefer to model your own tooth, go for it. That works too. If you set a new pivot point but nothing happens when you try to move your body, you probably forgot to confirm the new pivot. Once it's confirmed, you can finish the Move command and zoom out a bit to get a better view of your setup. Next, we'll create a 3D sketch. It's simple and it serves as a framework for the next steps in the workflow. Choose the vertical construction plane as your sketch plane to keep everything centered. Orbit into position and snap your first line to the center of the shaft. The length isn't important. Oversketch it to move faster. Then, turn this line into a construction line since it's just a guide. Next, snap your second line to the center of the tooth and draw it downward at a 135-degree angle. That's simply 180 minus 45. It gives us the correct slope while pointing the line in the right direction. Let it cross the first line. Trim away the excess from both construction lines and finish the sketch. Now that we know what to loft and have a guiding profile for both angle and length, it's time to use the solid loft command. You'll recognize it by the blue color. It's used for lofting solid bodies, which fits this workflow. Start by selecting the end face of the tooth as your first profile. Then choose the point where the two construction lines cross as your second profile. Before you confirm, don't set it to a join operation right away. You want the loft to connect only to the tooth, not the entire shaft. To play it safe, turn off the visibility of the shaft before you confirm the join operation type. Once that's done, things should look good. This is also a great time to make any other small adjustments before moving on to create the pattern. If needed, use the full round fillet. It's easy to apply and fully parametric, so it will automatically adapt to any future changes in your geometry. Create a circular pattern using the feature you just made. Select the center axis so the pattern rotates around the origo. Make sure distribution type is set to full. This ensures it goes a complete 360 degrees. Once the pattern is in place, you'll see everything lines up nicely thanks to the center design. But there's an empty space behind the pattern. We'll fix that next. Place a point at vertex where the pattern ends. This is also a good time to save your project if you haven't done so in a while. Use the loft command from the solid modeling tools to loft the circular profile up to the point you just placed. I kept the operation set to join, but since we're not focusing on organizing components or bodies in this tutorial, you could choose another operation if it suits your workflow. Next, create a section analysis for a quick quality check. If the cut ends up on the wrong side, just hit the flip button. This tool makes it easy to inspect the inside of your model and catch any issues early. Let's flatten the top before cutting a hole through the model. In this example, I'm placing a construction plane just in front of the model to use as the base for the next step. If you want a more advanced and future-proof workflow, you'd create a sketch plane that adjusts automatically when the 3D model changes. That takes a bit more setup but offers better parametric control. With the sketch plane ready, draw a center rectangle and use Extrude Cut to remove the unwanted top section. I went with this quicker method because it's simple and gets the job done fast, but if you're designing something that needs to adapt over time, the parametric route is more robust. This flat surface makes a perfect base for the circular sketch. It's a quick and simple sketch, but it's worth noting that while outside the scope of this tutorial, you can take it further. If you want your sketch to stay linked to other features during future changes, there are ways to make that relationship more robust. Now use Extrude Cut to go through the entire model. This method is both simple and reliable, and it's better than setting a fixed distance, because you're linking the cut directly to the model's geometry, which keeps things more stable if the design evolves. And that's it for this tutorial, where we focused on building a quick concept for a straight bevel gear. I prioritized speed over proper model management and didn't organize the design into components, which does come with trade-offs. For example, adding appearances at the end gets a little messy. If you have any questions, ideas or feedback, drop a comment below. And to all you subscribers, I'll see you soon in another Fusion project.